So what is this NAT all about? Don't forget, I said something to one of my students. I say every technology that I teach, it's to solve a problem. Any technology you see us talking about in class, that technology is just to solve a problem. So what does NAT come to do for us? Which problem did it solve for us? How does it operate? And we are going to have to talk about the configuration also. So we're going to talk about NAT for IP version 4 majorly. And then we're going to talk about the main stuff we need to do here is the configuration. We need to learn how to configure NAT. But if you don't understand the technology, configuring it becomes a problem for you. So we're going to talk about NAT characteristics. Under it, we're going to talk about the purpose and the function of NAT. We're going to talk about types of NAT, different types of NAT. We're going to talk about NAT advantages and disadvantages. We're going to learn how to configure static NAT. We're going to learn how to configure dynamic NAT. We're going to learn how to configure paths. I am not going to talk about NAT IS64. It's just an explanation on how we can tunnel IP version 6 through IP version 4. Temporarily, it's a temporary solution, not a permanent solution, because you don't need NAT in IPv6. So NAT characteristics. So what is NAT? What is NAT and why do we need NAT? Let me give you background. You know, I always like to give you background before I move, I travel far. Why do we need NAT? Remember when we were talking about IP addresses, we said IP addresses, you have two types of IP addresses. We have private IPs and you have public IPs. Why do we need private IP? To build our local area networks, all those 10.0.0.8, 192.168. And we said private IPs are not routable, meaning they cannot browse the internet. What about public IPs? Public IPs are routable. Those are the addresses that can go to the internet. So this is the idea. When you want to build your local area network, you're not thinking about internet for now. You connect computers together on a switch. You decide on the network address to be given to that network. And most of the time, it's always class C because class C is a small IP address and private IP address in class C. If you go back to our IP addressing, you see that this is a private IP address in class C. Now, if you have computers on this network, they are all talking together. They can ping themselves. They can share resources. They can share fold. They can share printer and all kinds of stuff. The moment you want to connect to the internet, you bring in a router, and your router connects to your ISP. This address you have here can go to the internet. This private IP address cannot go to the internet. Why can't it go to the internet? By the time the message or the traffic gets to the ISP's router and is going with the private IP address, do you know why? Okay, let me tell you something here. Why is it that private? Who is that? Help us find out and find the person. Gedza, can you please mute yourself? Okay, thank you. Now, I said something. I need to reverse back. I said private IP addresses are not routable. They can't browse the internet. Why can't they browse the internet? The only reason why private IP addresses are not routable on the internet because access lists have been configured on all the routers on the internet to block private IPs. All service providers have been informed to configure access control lists to block private IPs. And why did they have to block private IPs? Because that's a decision made by the powers that be. Before, there was nothing like private IP, public IP. All IP addresses are routable. All IP addresses can go to the internet. But in order for us to maximize public IP addresses, in what sense? I will explain. In order for us to maximize public IP addresses, they decided to divide IP addresses into two, call some private, call some public. Let me give you an idea. Let's assume in this network now, you have 254 users. For these 254 users to go to the internet, they need 254 IP addresses. And if all the IP addresses are IP addresses that go to the internet, we're going to burn down 254 IP addresses. Then somebody came up with the idea, why don't we call some addresses private and call some public? These 254 users, we can just give them one public IP. Only one. And all of them can use this one public IP. So in other words, we will be able to manage the public IP address because some are using the so-called private IP addresses within, and if they need to go out, they have to use public IP. And who gives this public IP address? The service provider. If there's another network somewhere in another country or even in the same country, the person can still use the same 192.168.100.0 for his own local area network. The moment the person wants to go to the internet, the person is given a different public IP, maybe just one or two or more. This person is going to go to the internet with that different public IP. Or let me say, the people on this network can use this public IP address to go to the internet. So, but there is going to be a problem. If the service provider gives you a public IP, where are you going to put the public IP? You have to put it on your router. And once you put the public IP on your router, you now have to tell the router, when people are coming from this IP address, translate their private IP address to this public IP address. And as soon as they hit the service provider is not going to see the private IP, it's going to see the public. Why? Because we have configured what is called network address translation. That is just the idea. The idea is on the inside, on your internal network, you use private IP. But when you want to go out, you use public IP. Who does the translation? It is our router. There is no network in this world, you see, none that does not do NAT. Every single network on the net, or let me say, don't let me say all, let me say almost 99%, because you may not need NAT if you are running BGP, meaning all your IP addresses here are public. Like in the University of Jos where I work, we have public IP addresses everywhere, so we don't need NAT. But as long as you are using private on the inside and public on your router to go out, that public is what represents you on the outside. You need to configure NAT on your router. That is just the background to what we are trying to do. So what is NAT? The primary use of NAT, I hope I didn't skip something. Okay, no, I'm supposed to start from here. IPv4 address space. You remember we talked about this when we're talking about private and public IP address. This is the only private in class A. These are the blocks of private addresses in class B. And this is the only private in class C. If you want to build a network, you must go for private IP address. Don't pick public. Why won't you pick public? Somebody somewhere is using that address on the internet. Any network you want to build, internal network, you go for private IP address. If it's a big network, you go for B or A. If it's a small network, just go for C. And if it is even very, very small, so subnet your C so that you can have multiple subnets to take care of all different the different networks. Let's go through. Networks are commonly implemented using private IPv4 address. That's what I just mentioned now. Private IPv4, which is defined in RFC 1918. That is request for comment. That is the documentation or the white paper that talked about these IPv4 addresses, the private IP addresses. Now watch out now. Private IPv4 addresses cannot be routed over the internet. Once you see 10 dots, 172.16, 172.17, 172.18, all the way to 172.31, they cannot go to the internet. 192.168 cannot browse on the internet. And I just told you why they cannot browse on the internet. Because all the routers on the internet are being configured with access control lists to block private IP addresses. So private IPv4 addresses cannot be routed over the internet and are used within an organization or site to allow devices to communicate. Did you see that? locally. That's all we do with private IP. We communicate locally. So to allow a device with a private IPv4 address to access devices and resources outside of the local network, watch out. The private address must be translated to public address. So it means you are going to have private on the internet network or for the internet network, and you're going to have public IP address or addresses for outside network. Who is going to give you this? Your service provider. Who gives you the private? You decide. Anyone you choose. You're okay. So your private IP address must be translated to a public IP address. That is the only way you can browse the internet. Outside of that, you can't go to the internet. And that's just the technology. NAT, which is Network Address Translation, provides the translation of private addresses to public addresses. Network Address Translation provides the translation of private addresses to public addresses. As far as I'm concerned, this technology or this particular topic is more important to me than OSPF. Because not many people use OSPF on their network. But you hardly find a company or an organization that does not use NAT. So you need to know NAT the way you know it, like you know yourself. So look at something here. This is our edge router. Edge router is a router that connects to the internet, one leg out. On the inside here, that's internet network. It's using private IP. On the outside, it's using public version, public default addresses. So what's going to happen? This router must have been configured with NAT. So that when people are coming from here, they hit this router, it translates from private IP addresses because you have more than one user and they all go out. And when they are coming back, they come back and they continue using their private IP addresses within. So what is the real essence or the real use of NAT? I've just explained that to you guys. The primary use of NAT is to conserve public IP addresses because we don't want to give every single person that needs to go to the internet a public IP address. We not say, okay, let them use private on the inside. And when they are going out, they use public. And guess what? One public IP address, let me put it this way, 65,535 users can use one public IP address. See the number. So they have been able to maximize or conserve the public IPv4. And that is why the public IP address is lasted. Now the addresses are finishing. That is why the world is now moving to IPv6. I heard that China is already on IPv6. All their networks are built on IPv6 completely. And other continents are following gradually. Why? Because we no longer have public IPv4 addresses again. The service provider have given them out. They are even retrieving some from some countries that have already moved to IP version 6. And without these public IP addresses, you can't browse the internet. So I need you guys to keep on cracking your brain right now because I need some questions that some people asked me, is it 2 years ago, when we go to this environment. So what's the job of NAT? NAT allows networks to use private IPv4 addresses internally and translate them to a public address when needed. Look at another example here. These people here now. Here, 192.168.10.0. Here, 192.168.11.0. If this computer is 10.10, 192.168.10.10, 192.168.11.10. If they need to talk to themselves, they don't need to. We don't need that. But the moment they want to go out through this router, this service provider does not know anything about private IPs. He doesn't know anything about private IPs. It wants to only see public IP. So if you are going out, we must have enabled NAT on this router too. So to say if 192.168.11.10 is going out, translate that IP address to public IP address. If 192.168.10.10 is going out, translate that IP address to public IP address. That is the only way you can go to the internet. Yeah, Mr. Samuel, let me read your question. Please, if you have questions, keep them coming in. In practice, is this ratio 65,532 to one public IP address visible? No, because you are not going to put 65,000 users on the network. We've talked about segmentation. Even in on campus network, where you have like 17,000 or 20,000 users or 25,000 users, like in universities, for instance, now. Some even have over 30,000 users. You are not going to put 65,000 users on a particular segment. You are going to segment the network. But will all of them now use this one IP address to go? No. You are going to have more than one. You are going to have pool of addresses. We're going to come to that. Because if you have only one, there's going to be a problem. Even though 65,000 can go with one successfully. But you are not going to work with that. We are going to come to that. So let me read this question to you. To you guys, he said, how does the system do it? That's the router now. When many users are trying to use the internet at the same time, and there's just one public IP address, how will you know the difference between user 1, user 2, user 3, user 4? How will you know it? We're going to come to that. I hope that I will answer your question by the time we are done with today's class. If you guys are tired after 1 hour and a half hours or 2, if I've not finished, I'll give you a break and then we'll come back again. Today's class, today is the last day. So there is no procrastination or let's finish it next week. Today is the last day. If you need to make coffee, after 2 hours, I'll give you a break. You go and make coffee. Today, now, today, yes, Mr. Samuel. Okay, so I'm going to get there. A NAT router typically operates at the border of a stub network. Anytime you hear a stub network, it's a network with one exit, only one exit. So a NAT router is always operate at the border of a stub network, or is at the border of a stub network. Look at this now, router now. It has only one exit to go out. There is no other exit. So this is called a stub network here. When a device inside the stub network wants to communicate with a device outside of its network, like on the internet, the packet is forwarded to the border router, which performs the NAT process, translating the internal private IP address of the device to a public outside routable address. I've explained that already. So this is how NAT works. They're trying to explain it to us. Look at one PC here. This is one PC here. It's connected to this router. This router is connected to another router. And then, of course, we have a server on the internet. When you see this always signify a server. So now, this guy is 192.168.10.10. You want to go and talk to this 209.165.21.1, maybe like Google, for instance, now. So what's going to happen? Look at it here. PC1 wants to communicate with an outside web server with the public IP address 209.165.201.1, which is this guy here. So how's it going to happen? The first stage. PC1 sends a packet address to the web server. If we use its IP address here as a source, use this one as the destination. I did a video for somebody on address resolution protocol. I think I demonstrated ARP better in that video than in this your class. I'm going to drop that video for you guys later so that you guys can watch that again. So what happens? Router 2 receives the packet and reads the source IP address to determine if it needs translation. Number 3, router 2 has mapping of the local to global address to the NAT table. When you configure your NAT, there's a table created for us. Number 4, router 2 sends the packet with the translated source address towards the destination. What does that mean? This is the address of the guy that is traveling out. When the router check its NAT table, it discovered that this guy, this whole network, have been configured to map to this IP address. So it's going to go out with this as a source IP address, representing this guy here. The 5th one. So what happened? That is, look at the fourth one now. R2 sends the packet with the translated source address, which is this one A, towards the destination. The web server responds with a packet address to the inside global address of 209.165.200.226. When the server is responding, it's responding back to this IP address because this is the source. So how will the router deal with this now? The router receives the packet with the destination address of 209.165.200.22. Router 2, this guy here, checks the NAT table and find an entry for this mapping. You know this one, there's no NAT here. This is where the NAT is. R2 uses this information and translate the inside global address from 209.165.200.222 to the inside local address 192.168.10.10, and then the packet is forwarded to PC1. Whenever NAT is involved, your address is translated to another address, which is always public IP address. This is how it works when NAT is involved. If NAT is not involved, you're going to see from this my address resolution protocol video that I did for a different class. That's how NAT operates. So now, let me emphasize on something here. If you don't have NAT here, this guy cannot go to the internet. Why? It only has private IP address. So there must be public IP address before you can go outside of your network. There must be public IP address before you can go outside of your network. Take note of that. Am I communicating before I proceed? Because this is an important topic, very important. Core. Why do you need the global, inside global address? The first question should be, what is inside global address? That's Mr. Samuel. What is inside global address? That should be the first question before you ask, why do we need it? Are we good? Can I proceed? I will soon demonstrate. I just want to finish some of the story, then I'll demonstrate. Okay. So there are terminologies you need to be aware of when you're talking about NAT. Thank you, guys. NAT include 4 types of addresses. The first one is inside local address. The second one is inside global address. The third one is outside local address. The fourth one is outside global address. Anytime you hear global, whether inside or outside, it's just talking about public IP address. Anytime you hear global, it's just talking about public IP address. And anytime you hear local, especially the inside local, it's talking about our private IP address. So like in this case right now, inside local address is pointing to our private IP address locally. And inside global address is pointing to our global IP address, public IP address locally, the one given to us by the service provider. There's a debate on this one. I always explain it this way to my student. The private IP address on the outside, somebody's private IP address out there. I don't want to go into the debate. And then, of course, this one is easier. Outside global address, that is the public IP address of a particular server on the internet where you are going to. So this is where I always explain this to my student. If I am here, I have a network here. I have 192.168.100.0/24 network. This is my inside global. If you, let's say this is Ali's network somewhere in Pakistan, Ali's in Pakistan. He also has 192.168.100.0/24. To me, this is inside local. To me, this is outside local because this is private IP address on the outside. To Ali, this is outside local address. To me, this is my inside local address. To me, Ali's private IP address is outside local address. And whatever I have here, any public address I have on the inside is inside global address. If Ali has another public IP address that he's also using on the outside for him to go to the internet, to me, that is outside global. If I want to go and hit him, hit his server or hit his public IP address, that is outside global. So these are terminologies you need to be aware of. Take note of that. Inside local address, inside global address, outside local address, outside global address. These are terminologies under NAT. So I don't want to waste time on this one. Inside local, private IP, locally. Inside global, public IP, locally. Outside global, private public IP. That is outside. Then outside local, private IP on the outside. There's a debate. There's a kind of a confusion on the outside local, but I don't want to get there. So let's leave it there. Yes. Oh, Mr. Samuel, what did you get now? I've not answered your question now. Please keep on talking to me. I'm enjoying that is the questions. You say you got it now. I've not answered your question. You say, why do we need global address? That should have been the first question. What is inside global address? That should have been the question, not why we need it. I like that. I'm enjoying it. Please keep it going. Good, good, good. I like that. I like that. So this NAT. There are different types of NATs. Different types of NATs. The first one is static NATs. Static NATs. This is the only NAT I've not been able to demonstrate successfully for a very long time. But I sat down with it yesterday. I cracked my brain. I said I must find a way to demonstrate this static NAT. I always demonstrate dynamic and the last one, port address translation. This static NAT, not that I can explain it, I can configure it, but I've not been able to show students how it works until yesterday. You know, I always confess my sin in the class. That's one of the reasons my students like me. They said I'm down to heart. If I don't know something, I say, guys, I be like, say, this thing don't confuse me. So what is static NAT? Static NAT uses a one-to-one mapping, take note, of local and global addresses configured by the network administrator that remain constant. It is a one-to-one mapping, meaning we are going to have one private IP address and one public IP address and map the two of them together on our router and tell the router this private IP address is mapped to this public IP address for what? For coming there. Static NAT is useful for web servers or devices that must have a consistent address that is accessible from the internet, such as a company web server. I'm going to explain to you guys now. It is also useful for devices that must be accessible by authorized personnel when offsite, but not on the general public on the internet. So this is the idea. You have a server within your organization. That server can only use private IP address within. You are somewhere on the internet and you want to be able to access this server as the administrator. How do you enter this server? You cannot enter this server with private IP on from the internet. It's not going to work because private IP address don't travel on the internet. It must be public. So what do? We go and tell our router. We are going to tell the router, see this private IP address. Anytime somebody is trying to enter, let's assume 209.165.200.226, direct the traffic to this server. We are going to configure static NAT on our router and map this public IP address to this private IP address. So what that means is the moment you want to have a remote login, that is like SSH now, secure remote login, you want to access this server from anywhere in the world, you don't need to use the private IP because it won't even work anyway. You just use the public IP that you have used on your router. You hit that IP address, and guess what? The router will redirect your traffic to the server within. That is the use of static NAT. Even though I didn't configure my own SSH because I don't have a server, but at least I have a system on the network that I can ping. Once I can ping in, I can SSH into it or telnet into it if I configure if I brought in a server down for that, but I didn't use a server, I only use a computer. But just know that the use of static NAT is for you to be able to hit your server from outside. You configure, you map the private IP address of that server to the one of the public IP addresses that you are going to have from your service provider, so that you can access the server from outside. You can see an example here. We have other things, other computers on the network that they also map. 10.11, 10.12, all of them were mapped statically. So you may want to access this system from outside. You may want to access this one from outside. As long as you have static NAT working, you are good to go. Note, static NAT requires that enough public IP addresses are available to satisfy the total number of simultaneous user sessions. If you have multiple people that will be coming in, you need more public IP addresses. You need more public IP addresses. That is one. I said there are different types of NAT. The first one is static NAT, and I'm going to demonstrate it for you guys. The second one is dynamic NAT. This is the one most people use everywhere, because plenty users want to go to the internet. They are going to hit the router. The router is going to be converting their private IP addresses to public IP addresses. So we want it done dynamically. We're just going to tell our router, give the router a pool of addresses. Like in this scenario now, they have 226, 227, 228, 229, 230. Maybe somebody is giving this one. Another person is giving this one. Another person is giving this one. It's not going to be a static. So this is more or less used for people inside that are going to browse the internet, or not the other way around. Static NAT is mainly used for people that want to access a server within the organization from outside, while dynamic NAT is for us that are on our private network to be able to go out using multiple or pools of addresses. And we're also going to see how to configure dynamic NAT. Dynamic NAT uses a pool of public addresses and assigns them on a first come, first served base. When an inside device requests access to an outside network, dynamic NAT assigns an available public IPv4 address from the pool, because we're going to create the pool. The other addresses in the pool are still available for use, just like what you saw in this play. This is available, this is available, this is available. Note, dynamic NAT requires that enough public IP addresses are available to satisfy the total number of simultaneous user sessions. Just like Mr. Simon was asking me, what if all these addresses are in use? What happens to other people on the network? You may have a little delay. But what you need to know is this. Two people don't go to the internet simultaneously. Somebody is in, somebody is resting. Once somebody is resting, the router picks the address or he makes it available, and then the person can use it to go. And the third one, which is the last one, is called port address translation. This is the one we normally use when we want to map like 65,535 to one public IP. When you are using the normal NAT, it's one-to-one dynamically. That's why you need pool of addresses. But if you don't want to use NAT, you want to use just one public IP address, then you have to activate port address translation. Another way to refer to port address translation is NAT overload. NAT overload. So this is what some people do. All you need is just one public IP address and you are good to go. But if you have just one public IP address and you went and activated NAT and you have plenty of people on the network, some will browse, some will not browse. Some will browse, some will not browse. Some will browse, some will not browse. So how does PAT operate? What's the difference between PAT and NAT? Port address translation, which is also known as NAT overload, watch out, maps multiple private IPv4 addresses to a single public IPv4 address or few addresses with paths. When the NAT router receives a packet from the client, Mr. Samuel, watch out now, you ask a question. It uses the port source port number to uniquely identify the specific NAT translation. Because when you are sending out, you are coming with a particular source port number. So if we configure paths will make use of that source port number to lock you down to that IP address, to the public IP address. If another person is coming, the person is going to come with a different source port number. Even though all of you are going to be using just one public IP address, the source port number will be different and your destination port number will be different. What I'm requesting for is different from what you are requesting for. But we are all going to come to the router with different source port number. We discussed about port number under OSI modem. Look at a good example in this case. 192.168.10.10. The guy is coming with 155 source port number. 192.168.10.1. This one is coming with a different port number. This is what the router will use to know that this message belongs to A, this message belongs to B, even though all of you went with the same public IP address. By when the message is coming back, it has locked down the source and destination port number of each of you and know that, okay, it's 10.10, 192.168.10.10 that came with this source port number. It's 192.168.10.11 that came with this source port number, and it knows how to give the messages directly to you, so there's no confusion anyway. Look at, for instance, now, they came with different source port numbers. They were going to the same destination port number. When the result comes back, or the reply comes back, it knows that 10.10, 192.168.10.10 is the one with this port number. It gives you your message directly and give the other person the message directly, so you can't mix it up. But if you do not configure paths, you configure only NAT, and you have this kind of scenario where you don't have enough public IP addresses, some people will browse, some will not browse. And you're going to come across this in your exam. Where they will tell you, oh, some people couldn't browse. What do you think the problem is? I'm not saying your final exam you are writing next week. I'm talking of certification now. Because sometimes they bring this kind of question out. What do you think the problem is? By the time you take a look at the configuration, you discover that they did not configure paths. They only activated NATs. And that is not going to work. Path ensures that devices use a different TCP port number for each session with a server on the internet. And this is what I've just explained. So we have static NATs. That is now the first one. We have dynamic NATs. That is the second one. And we have paths, which what we call dynamic NAT overload. Dynamic NAT overload. So we're going to see the configuration of them one after the other. Very simple configuration, but you need to understand the concept there. Well, static NAT, dynamic NAT, and path. So what is the difference between a NAT and path? Summary. Look at NAT here. One public IP address, one private IP address. Nothing more. But look at paths. Port number is added. Port number is added to the private IP, to the public IP. Let's come to this table here and see. For NAT, one-to-one mapping between inside local and inside global. For paths, one inside global address can be mapped to many inside local addresses because you are going to have different source port numbers. For NAT, uses only IPv4 addresses in translation process. For paths, uses IPv4 addresses and TCP and UDP source port number in translation process. Port must always be involved. That's why it's called port address translation. Then the last part, under NAT, a unique inside global address is required for each host inside accessing the outside network. So if you are going, you need your own IP address. If I'm going, I need my own public IP address. If you don't have enough, somebody is not going to go. But for paths, a single unique inside global address can be shared by many inside hosts accessing the outside network. So we need to know the difference between the three before we come to configuration. Am I communicating? Any question? Okay. Thank you, guys. All right, so let's talk more, and then we'll go to lab. What are the advantages and disadvantages of NAT? In IPv6, there is no NAT because of this. Some of these disadvantages. NAT provides many benefits. We've mentioned some already. NAT conserves the legally registered addressing scheme by allowing the privatization of intranet. Any address you are using on your network, I can use it on my network internally. Another person can use it because all of us, we do NAT when we are going out. NAT conserves addresses through application port level multiplexing. That is port numbers issue. NAT increases the flexibility of connection to the public network. It's not a big, there's no big deal. Set it up and you forget about it. People are connected. NAT provides consistency for internal network addressing scheme. You can change your public IP address. Your private address doesn't need to change. And it's also almost the same thing that is here. NAT allows the existing private IPv4 addressing scheme to remain while allowing for easy change to a new public addressing scheme. It's almost the same thing with what they said, the consistency of internal networking addressing scheme. Now look at the big deal about NAT. NAT hides the IPv4 addresses for users and other devices. This is a plus. It's a security feature, but it's also a problem when the government agencies are trying to trace you if you're a criminal. Because you are coming to the internet with a public IP address. If you are committing crime, they can only trace that crime to that public IP address. They don't really know who committed the address, except they come into the network and now come and check the table, the NAT table of the router, and know that, okay, this person that committed the crime came with a particular port number, and then they can trace that one down. So end-to-end traceability is difficult with NAT. It's a security feature because somebody cannot really attack you directly from the internet easily. But when it comes to government agencies trying to track the bad guys, this is a minus for them. That's why they love IPv6. They are happy with IPv6. It doesn't matter where you are in the world. With IPv6, they can pinpoint you, your location. It's not a big deal. So what are the drawbacks of NAT? Which are the disadvantages? NAT increases forwarding delays because the router has to do conversion, translation. There's a little delay. End-to-end addressing is lost. You can't trace destination because there's a public IP address in between that's been translated. So you don't know who's at the other hand. You don't know if it's only one person that's at the other hand. So it's almost the same thing with end-to-end traceability is lost. So government agencies are not happy with this. And this is a problem for NAT again. NAT complicates the use of tunneling protocols such as IPsec. I taught you that I dropped a video on IPsec. If you listen to that video, if you are doing NAT, you need to have some other configuration before it can work. If you don't have those configuration, your IPsec VPN will not work. So that is if you are using NAT. But if you are not using NAT, what I taught is simple and straightforward there. Services that require the initiation of TCP connection from outside network or stateless protocols, such as those using TCP, can be disrupted. There are some services that need end-to-end communication. And since we don't have end-to-end communication as in traceability, those services cannot be used. These are the disadvantages you have with NAT. But the advantages outweigh the disadvantages. So we cannot but use NAT. Now, we are still using NAT and we'll still continue to use NAT until we completely move to IP version 6. And this may not be in our generation. I hope that is clear. So now, we now have to take this NAT one after the other and see the configuration. So the first one is static NAT. I've said it's a one-to-one mapping. It allows you to come in from outside to access your server and all of that. So how many steps do you need to configure static NAT? Just 2 steps. There's something I'm looking for. I've not seen it. I've not seen it. Okay, I will just explain it to you guys. So just 2 steps for us to configure static NAT, and we are good. So there are 2 basic tasks when configuring static NAT translation. Number one, create a mapping between the inside local address and the inside global address using this command, IP-NAT inside source static. Look at the way they use the command here. IP-NAT inside source static. The private IP address and then the public IP address. This is the private within. This is the public they want to map to that private. So if I'm coming to hit this particular computer from outside or the server, I need to hit this IP address and the router will push the message to this. That's step number one. Step number two, the interfaces participating in the NAT in the translation are configured as inside or outside relative to NAT with IP-NAT inside, IP-NAT outside. This is the one I said I have not seen. For your LAN connection, let me go to my packet tracer and see this. Look at my design here. Can you people see my packet tracer? Okay, good. So I built this network before the class. Look at what I have here. This is my university where I work. This is our local area network. And look at our private IP address here. This is our service provider. This is our imaginary user on the outside that want to come in, to come and access, let's say, this computer here. Let's call it a server. This computer here is server 1. There's a connection between the University of those router and the ISP. That connection can be, private IP can be used. But guess what? The ISP need to give me pool of addresses. Look at what they gave me here. I gave myself imaginary pool public IP addresses, which is 200.100.100.0/28. I have up to 6 usable, 1 to 6. If you go and do your calculation, 1 to 6, is it 1 to 6? /28, that is 0 to 2 raised to power 4. How many bits is left there? Yeah, 2 raised to power what now? Yes, that should be. Let's do calculation now. /28. What will be the range? That should be 0 to what? 0 to 0 to 15. That should be 0 to 15. I think I have more than 6 there. Subnetting gurus, help me out. If we borrow how many bits? 1,
Yes,
2,
sir.
3, 4, 5,
Yes, sir.
6.
2 raised to power 4.
2 raised to power
2 raised
4.
to power,
That
that's
is
16.
16, right? And so
0
we
to
have
15.
0 to 15. So the usables are from 1 to 14, right? So I have
Yes, sir.
1 to 14. Thank you. So now, this is the imaginary public IP addresses I gave myself. Now, you know what? Most of the time, service provider don't give you more than 2. I will come to that again later. They give you most of the time /30, 2 public IP addresses. But if you are paying for it, you are entitled to minimum of, I think, maximum of 6. But if you don't know, they will just give you 2 and keep quiet. I didn't know 2 until we did a job like 3 years ago. That was when my friend and we did the job together. I said, nope, we're entitled to 6 public IP addresses. So he called them and they released the remaining public IP addresses for us. So now I have 14 public IP addresses. Look at the network address that I have here. I have configured this router. I've not done anything NAT here. Nothing. The only thing I've done is I have pinged from here to the gateway, from here to here, from here to here, and I also did default routes here. You guys know that I told you any router connected to the service provider must have default route. IP route 0.0.0.0 and all of that. And I've also configured static route on this router. Now listen, I need your attention now. Your service provider won't configure static route to this LAN. He has no business with your LAN. He will configure static route to point to the network he gave to you, because that's the network he wants to reach. He needs to know about that network in your routing table. Take note. If you follow what I taught you in static route, you're going to tell this router about this network. You're going to tell this router about this network. When we're talking about service provider, they don't have any business with your LAN because you are going to do NAT. They will configure their static route to point to the address, the public IP address they gave you. So let me show you what I've done here. This unit just router, show run, me and section command. Let me try include a static route and see if it will work. No, this is not going to bring. Let's use section. So if you should try to master the filter command, let me go to my show run JJ. This is what I'm trying to filter out here. Look at what I did. I configured default route. Why? On edge router that goes to the internet, there must always be a default route. I said that when we did our static route, because this router is going to send any message it doesn't know to the service provider. Somebody is going to Google, it doesn't have the Google address, it forwards to service provider. Somebody is going to Yahoo, service provider, Amazon, service provider, Facebook, service provider, Instagram, service provider, any network on the internet. So we'll simply say, if you have a message for any network, and you don't know the network address, you don't know the subnet mask, you don't know where the person does send it to service provider. That's the service provider's headache. And the service provider knows about all the networks on the internet. So don't ever forget this. Then if I go to the service provider, now in the real world, we don't have access to the service provider's router. But I just need to tell you, this is how I make this work in the lab. So if I go to the service provider, look at what I did, apart from basic configuration, show run. I created a static route pointing to the public IP address given to me by the service provider. Take note, a static route pointing to the public IP address given to me by the service provider. And that is exactly what the service provider will do in the real world scenario. They will point to the public address they gave to you, because that is the address that will be representing your LAN. The network address given to you, the public IP address given to you will be representing your LAN. That is the one that service provider is concerned about. So those are just the things I did. So now, what do I want to achieve right now? This is Ali, somewhere in Pakistan. You want to access my server in the university. Let's assume this is a server. Huh? So what do I need to do? I configure a static NAT. Map the IP address of that computer, which is like my imaginary server. I think that guy is 1.2. And map it to a particular public IP address on my router. 100.100.100. Let's say .2 again, and give Ali this public IP address. Wherever Ali is, even if he travels out of Pakistan, anywhere he is in the world, as long as he's on the internet, he will hit this IP address. He can ping it, he can SSH into it. The message will go through the service provider, through all kinds of service provider on the internet. At the moment he hit my router like this, the router will check his NAT table and sees that this public IP address has been mapped to this private IP address. Boom, it will forward it to this particular computer. Let's see how this will be done. Before we do it, I was going to explain something. Anytime you are configuring NAT on your router, you must define the interfaces as inside or outside. Like this network, this LAN now, this is our internet, this is the interface that connects our internet network. I will go to that interface and say IP NAT inside. I need to let my router know this one is my internet network. This is the interface that connects to the outside world. I will go to that interface and say IP NAT outside. If you forget these commands, your NAT is not going to work. IP NAT inside on the internal interface, IP NAT outside on the external interface. So let's do that first before we do our NATs. And let's go to Unijust router. I'll go to this router and go to those interfaces and make this happen. Interface G0/0. Look at the command IP NAT inside. This is the interface that connects to my this is where we are translating from. Then I'll go to the other interface G0/1. I'll say IP NAT outside. This is key. Now the next thing I need to now do is they did that secondly. It was their second stop, but I like to do it this first. We now want to create our static NAT on Unijust router. I'm going to say IP NAT static. Is that IP NAT static? What's that command again? Let me check the command.
IP NAT inside.
IP NAT inside. Thank you. IP NAT inside static.
Source.
IP NAT inside static. IP NAT inside source, sorry, static.
Yes,
IP NAT inside source, static. So what's the first thing I need here? The inside local IP. I'm telling my router 192.168.1.2. That is the inside local IP. Then the public is the next thing. What is it? Inside global IP. That is the IP address our lead will be using to come in. 200.100.100.2. I hit enter. And guess what? I'm done. I'm done with static now. So I'll call Ali and send him this IP address. Anytime you need to enter into the server, maybe it's our administrator, he needs to work on the server, or you need to manage the server or maintain the server, or do one or two things. Just use this IP address. It doesn't matter where he is located in the world. When you try to hit this IP address, the address will be translated to this private address. Before we translate, before we ping and say, let's check the NAT table. Show IP NAT translation. You see that in my NAT table, I already have these things mapped there. Why? Because this is a static NAT. It's a static NAT. It has to be in the NAT table. So now I want to go to Ali and see if Ali can hit this particular IP address. Public, don't forget. If he tries to go to private, he won't get there. Let's try. This is Ali here. Let's try to hit his I think I did this. Okay, no, good. The one I ping is different. One ping 192.168.1.2. You see what we find that? Oh, got here. Destination host unreachable. No way. No way. Okay. Ali can't get there with private IP. He's on the internet. He's not within my network locally. So what can we do? We give him public IP. Ping 200.100.100.2. That is the public IP that we're representing. Now, we're just doing testing now. If you needed to SSH or Telnet or have a remote login, that's a different ballgame. I will have used a server there. So if you can ping that IP address, then you can get in. So let's see what will happen. If this doesn't respond, then we'll have to do troubleshooting. I got this one how I work yesterday. I deleted it by mistake. Oh, beautiful. You know why we lost those ping? App. So now, as long as Ali can ping this public IP, he can SSH into that my computer or my server locally in Nigeria here. So what have we done? We've done static NAT so that Ali can come from outside and hit our web server. If you now go back to that router now and see that table again, you should see that some other things have happened to the table. The table has been populated and it's telling us what happened. ICMP is pointing to ping. You can see the numbers of packets that came in. You can see the number of packets that came in from the same IP address. Because I pinged twice. Some were lost, some were successful. So this is what I need you to see. Forget about what you are saying under outside local and outside global now. My concern now is on the inside global and inside local. Now, the outside global, of course, that is where Ali is coming from. But if you take a look at the outside local here, it's giving me the same address as is outside global. So don't bother about that. But the one you need to be concerned about is showing us its public IP address, where it is coming from, which is the outside global. So Ali can get this computer and our static NAT works. Is this clear to you guys? Does one command, or let me say 2 commands on our router. Mr. Patrick, I like the way you used to clap for me. Maybe others should also be clapping for me too. So I'll get energy. That's a joke anyway. Show IP NAT. There are other you can say statistic. You see the numbers of NAT that have been done. You can say show IP NAT translation. We have done translation already. So show history. Let's see the command that I just issued. Oh, let me go back here and say do show history. Look at the commands here. I enter this interface. I say IP NAT inside. I enter that interface. I say IP NAT outside. And then I went and did my mapping. And that was it. And we have just done static NAT. And it's working. A leak will come in. And if this is a server, it can SSH. Don't forget SSH is used for remote logging. Any question? Any question? Are we good? Okay. So let's now continue to dynamic. So I'm going to yank off these static NATs and move to dynamic. So what is the difference between static and dynamic? Let's see the difference. Dynamic NAT. People here, everybody need to go out. It's not about somebody coming, it's about people going out. And we need to have multiple pool of addresses for them. So we have to create the pool of addresses and tell the router, these are the addresses that we have. Just use any for anybody trying to go out. So what am I going to do? I have them, don't forget I have 1 to 14 that I can use. If I like, I can use 1 to 10 for dynamic and use 11 for static, use 12 for static, use 13 for static, use 14 for static. I can use just, I can divide them. So now that I've used 2 already, I have yanked it off, so no problem. So let me just use 1 to 10 for my dynamic, meaning all the users on my local area network, let's say 254 users, if they want to go out, they will all be using this 10 public IP address. Some will use .1, some will use .2, some will use .3, some will use .4, some will use .5, and so on and so forth. So let's see this at work. Let's see this at work. On the same Unijust router. Watch out now. When you want to create dynamic, you need to create a pool. Tell the router these are the addresses. How do you create the pool? IP NAT. I always forget some of this command. Pool. IP NAT pool. Then we name the pool. IP NAT pool. We name the pool. Let's say CCNA 3. IP NAT pool CCNA 3. What's next? The start IP address. Don't forget our public IP address is 200.100.100. From .1, I want to use from .1 up to 200.100.100.10. Then the next thing is net mask. That is the subnet mask of that net address 255.255.255.240. I hit enter. What am I telling my router? I have created a pool. I named the pool CCNA3. And I'm telling my router, I want to give you addresses from 200.100.1 all the way to 200.100.10. And the address that I'm giving you, this is the subnet mask. Take notes, you have to put that word net mask. That's the first command. The second command is to tell the router about our private IP address. Don't forget on our network here, my private IP here is 192.168.1.0/24. I need to use a command to qualify this network address. So, which command do we normally use to do that? We use access list. Now, don't get confused. We're not trying to block any traffic. Access list has so many uses, different ways to use access list. We're just going to use access to qualify our LAN. And it is private, I say private, standard access list we're going to use. So I'm going to see access list 1 permits 192.168.100, sorry, .1.0, wildcard mask 0.0.0.255. Permit it to do what? To go house. We did access list in the last class. This is a different ball game. I am using access list. I am going to tell my router, permit the people in this network to be translated to the public IP. That is the use of access list in this scenario now. So this access list we have here is just to qualify this network to be permitted to be translated. So how would I tie the two together? I need to tie the two together on my router now. I will now say IP NAT inside source, inside source, not static now. Pool, let me check. List 1. What is that list 1? This list 1 is pointing to my access list. IP NAT inside source list 1, then pool CCNA 3. IP NAT inside source list 1, that's pointing to my private. Pool CCNA 3 is pointing to my public. So what am I trying to tell the router? You are going to start translating from the private IP addresses qualified by access list to the public IP addresses inside the pool CCNA 3 and hit enter. And that's it. 3 command. Do show history. Look at the command here. Oh, this one is not part of it again. So you should be aware of that one. Look at the commands here. We created a pool, IP NAT pool, CCNA 3. We put the range from 200.200.1 to 200.200.10. We put the subnet mask. We created an access list. Not the way you know access list before now, to go and say, don't go out, don't come in, and all of that. No. We use the access list to qualify our network, the network that will be translated. The start statement is to say IP NAT inside source, that's the command, list 1, that is pointing to our access list. If it is access list 10, you say list 10. If it's access list 20, you say list 20. It must just be standard. Then pool CCNA. And ladies and gentlemen, we are done configuring our dynamic routing protocol. I say dynamic routing, dynamic NAT. So what will happen here? Some people are going, they will pick .1, 200.200.1. Some are going to pick .200.200.2. Some are going pick .200.200.3. Some are going to pick .200.200, and so on and so forth. So let's see this at work. First of all, let's clear our NAT table. Clear IP NAT translation so that that table can be empty. Star. So let's just show IP NAT translation. There's nothing in our table now. This is dynamic. That's why it's not in the table. So now I want to ping from here. This is our imaginary Google server. Before, this was Ali. I'm ping a public IP. Ali, can you still hear me? My network just showed me that is okay, good. That is having a problem. Okay, thank you guys. So now, so don't forget the dynamic we lost. Okay, I'm back. Okay. So don't forget the dynamic is about people here going to browse the internet, and that is why you get in most organizations. It's not about somebody coming in like we did. And we can have a combination of the two, dynamic and static. In fact, when we're done with this, and this is working, I'm going to put that static back and use a different IP address. Maybe use .11, since we have not used .11, and see if it will work. So I want to ping from here. to our Google. I want to ping from A to our Google, imaginary Google server, and see what happens. And see whether we can reach the IP address and see the translation the router will do. And don't forget, this is our dynamic. I mean, a dynamic NAT here. So what is this guy's IP address? IP config. This guy is 192.168.1.2. Let's see if we can ping our imaginary Google server. 200, ping 200.100.101.2. We see that we can go to Google. That's our imaginary server. Let's also ping from the other. Okay, let's check the NAT table first. Show IP NAT translation. What did you see? What did you see? It is 192.168.1.2 that pinged. That's his local, inside local address. Look at his inside global address. The router has given this guy 200.100.100.1. We went to way 200.100.101.2. Let's ping from another server, another computer, and see if that one will also be given the same public IP or a different one. Ping 200.100.101.2. This guy is also pinging, or he pinged also. So let's check our NAT table. Again, you see, this guy went out. This guy is 192.168.1.3. The router gave the guy 200.100.100.2. They went to the same destination, but the router gave them different public IP addresses because this router has from .1 to .14. So it's going to be shuttling in between .2, .3, .4, .5, .6, all the way to .14. So that's how people will be using. But if those 14 IP addresses are engaged, that's when you have some people not being able to browse the internet. This is how dynamic NAT works. 3 statements, and you are done with your NAT. Any question? I want to try something I've never done before. Let me put that static NAT back. Yes, Mr. Samuel, you have the floor.
Yeah, I typed the question on the chat, but let me just
see it. No, let me read it. No worry, let me read it. Sorry, I did not know you sent something. If we have more than one subnet, good question. Are we going to configure the mapping for each inside local IP address separately? So let's assume you have another subnet here. For instance, now we have a different LAN here, and there are computers here. And this place is 192.168.2.0/24. All you need to do is the same access list that captured this will also capture this. You see access list 1, permit, you put this one also. If you have another LAN again, maybe 3.0 network, access list 1. The access list 1 can take care of so many subnets. Meaning 1.0 will be translated, 2.0 will be translated, 3.0 will be translated. All of them will be translated. I hope that is what you're trying to ask. Is that what you're trying to ask? Okay, beautiful. Good question. I like that. So let's put Hali back, but give him a different IP address. Any address you are using for your dynamic, you can use it for static. We have used 1 to 10. So let's give Ali.11 to come in from outside and see if this works. I've never combined the two together. So let me see if it's going to work. So I'm saying IP NAT inside source, static, 192.168.1.2, 200.100.100.11. So I want Ali to use this to come in. So let's see if Ali can ping this address and check our table. Beautiful. This works. So let me check my NAT table. So I have combined both dynamic and static NATs together. So what's happening here now? Where's Ali? Ali is coming in with 200.100.100. It's coming in to talk to 200.100.11. This is where it was forwarded to or redirected. That's the right word. And this is Ali's public IP on the inside, which is also the same thing I is showing here. Even though this one is showing you outside local, that's the way our packet user shows this one. But this is actually at least public IP. So you can combine the dynamic and static together. Meaning people are going to the internet from inside, and you're still expecting somebody to come in from outside to access the server, and that works perfectly. This is the first time I'm merging the two together. So I've used 1 to 10 for dynamic. I have used .11 for Ali. If I have another person I want to map address for, I have 4 IP addresses left to do my static NAT. Is that clear? So know when to use dynamic, know when to use static, and if there is a need to combine the two, combine them together, and you'll be good. This is this is when I say, I don't want to just say core topic, core of the core. NAT, core of the core. Access list, core of the core. Default route. Core. These are things that almost everybody on the internet, every network you see, they must use all these things. They must do these configurations. They must do NAT. They must do. If they don't do these things, no way. Things will fall apart. Internet, there will be no internet connection. So this is a very important topic to us. So any question before we go to the last one? So what we just did is dynamic NAT. This is to take care of every other users on the network. Like in this scenario now, Mr. Samuel, you asked a question. Look at 10.0 network, 11.0 network. My access is captured this, access will capture this. I will just go and NAT these 2 subnets. And if you have more than that, I will map all the subnets. Just make sure you have enough public IP addresses and look at the configuration here. 3 steps and you are good to go. But don't ever forget your IP NAT inside and IP NAT outside on the interfaces. Look at what they did here. We configured the standard ACL to identify, that's a good word there, only those addresses that are to be translated. So that our access list is just identify the addresses to be translated. And the last command is to bind the ACL to the pool. So when you say list 1 is binding that ACL, is binding it to this pool. And the pool is pointing to the public IP addresses. And that's all. So don't forget your IP NAT inside and IP NAT outside. If you forget this, your NAT is not going to work. So analysis, I've explained all of the analysis to you guys. Okay, any question? Then we'll go to the last one. Look at this command. Take note of this command. Show running config, include NAT. You know, I'm trying to do all those filter commands. Show running config, include NAT. Clear IP NAT translation. Show IP NAT translation. So be aware of all of these commands. They are very good for you. Are we good? Okay, good, guys. Do you know now, what if I have 10 public IP addresses to use, 1 to 10? Let's assume I have like 60,000 people on my network. Let's say 60 is too much. Let me just say 20,000 users. Even though I know that 65,535 can use 1. What if I want to have more than 1 to be used between this? I don't have up to 65, I have just 20,000. I want 1 to 10 users to use this. Now, if you take a look at the way NAT operates, it's not having port numbers. The only reason why multiple users can use 65,000 is because they have port numbers. So we may want a situation whereby out of these 20,000 users, 100 people are using .1, 100 are using .2, 100 are using .3, 100 are using .4, 100 are using all the way to .10 or maybe 1,000, and it will still work perfectly. Different source port number will be attached. We have to configure paths. How do you configure paths? Another way to point to path is NAT overload. How do you configure paths? This is very simple. You know, for us to configure path, what we need to do? Let's go back to our, let's clear this, clear IP NAT. translation. I'll go back to my configuration. Watch how this command. Remember what we did with this command. IP NAT inside source. I didn't change anything. All the configuration we did for NAT is still, they are still there. IP NAT inside source list 1 CCNA. If I had just one word overload, my configuration has changed to parts. Adding this just one word, my configuration has changed to parts. Don't forget, I say another way to point to part is to say NAT overload. Once you had this one word, use your configuration that we had before has changed to port address translation. So configuring part is very easy. Just add overload and you're good to go. Mr. Samuel, what do you think? You said today, not today. Easy. I like that. Ali, what do you think? Haha, Mr. Patrick, you make me laugh. I like that. Just add overload and your configuration has changed to parts. So let's see what's going to happen. We added overload and now we're going to hit enter and see the way our router will now respond now. Let's now ping our imaginary Google server and see what will happen. Don't forget we're pinging Ali. We have turned Ali's router, our computer on the outside to imaginary Google server. So if I ping Ali now, which is Ali is 101.2 from this computer, and then go to the other computer and also ping Ali. Both of them can ping our Google server and then go to our table and see the way the table shows translation. You will see this time around, even though it's been showing this number, this is not normal. What I want to display to you guys, we've seen some number before, but without dots. I mean column rather, without column. Now adding column to this, let me check the other side. Do they have column? Oh, they also have column. They have column. So this is, we're not supposed to see those spots and numbers. That's the problem sometimes with packet tracer. But the difference is this time around, source port number will be added to all our computers that are going out. It will be added in the NAT table. Then map it to the public IP address they're all using. That's just the difference. But the configuration is simple and straightforward. But the difference from the output you're going to get is the source port number that will be added. Even destination port number will be added, and that will be in the NAT table when you configure parts. But if it is ordinary parts, I mean NAT, you're not going to get that. Let me see their own and see what they got from their table. Look at what they got in their table. And we didn't see this before. Other tables, source port numbers is added, source port number, destination port number, destination port number. But when you are doing ordinary NAT, you don't see those things in under NAT. Let's see their table for NAT. You see their own table, show up in that translation. There is no port number, no port numbers, no port numbers. You see that? We're not supposed to have port number. So that is just a problem with packet tracer. Is that clear? So on a big network, big organization that do not have enough public IP addresses, you configure NAT overload, which is also parts. One more thing, and that will be all. Any question? I want to get rid of this our NAT that we did. That pull everything. Everything. Because I want to show you something. This is our pool. I'm getting rid of our pool. It said it's in use. I cannot destroy it. There's a way to destroy it. I can't remember. There's a way to destroy it. Let me see. Yes, Mr. Samuel asked a question. Let me read. Are those port numbers? Because those numbers do not indicate known destination port. Of the one I showed you indicated the destination port number now. Look at port 80. Source port numbers are always dynamic. You know the range. Let me show you. Port 80. Look at this one now. This is a non-port number. Port 80 is HTTP. HTTP. Mr. Sam, have you seen that? The source will be any number between the range of, I forgot that range. Any number from 1 to 65,000. Yeah.
So I'm referring to the
Yes, sir.
packet tracer. Where we
No,
did
the packet tracer's own is not giving me what I'm looking for dynamic NATs. It's showing me port numbers for the output of dynamic NAT. That's not normal. If you're in a live router, you won't see that. It is when we go to the part, you're going to see those port number. But even at that, because we're in the lab, packet tracer will not show you non-port numbers, except you are simulating if you drop a server like that at least side. If I drop a server and configure it for HTTP, and then we're now SSHing into it, we SSH into it, then you're going to see port 80. Sorry, if we SSH, you see 20. What is the SSH? 22. If we are browsing with that server, you see port 80. But because I didn't use a server, I only pinged. Even the ping, it won't give you any known destination port number. But if you try this on a live router, this is what you get. You get known port numbers. Is that clear? Is that clear, sir? Mr. Samuel, is it clear? Okay, good. So give me some minute. There's a way to kill this pool. I want to get rid of the pool. I can't remember the command. Let me see. Play what? It's not clear in translation. Wow. I can't remember the command, but let me just explain some things to you. That place we applied it, let me remove that one so that that thing doesn't, the access list is not in. So let's remove this our part. The pool is there, but it's not going to work because we have not applied it. I've removed this one. Sometimes, please listen to me attentively now, listen carefully. Sometimes the service provider does not give you pool of addresses to use. Nothing. What's going to happen? How will you configure your router to browse the internet? They will not connect to you with a private IP address either. On this link, they will connect to you with public IP address. Maybe you are 200.100.100.1 on this your interface, and this service provider is 200.100.100.2 on the other interface. They will connect. This connection will be established with public IPs. We can use private, it works, but they will connect this. They will connect these things to you with public IP. So how will you now configure your NAT? All parts. What do we do in a scenario like this? Very simple, straightforward. As long as you have done your IP NAT inside, IP NAT outside, this is the only thing you need to do. If you are not given pool of addresses, you go to your router, look at this interface G0/1. I will go to that my router and say IP NAT inside, what's that command? Source. What's that commando? I think it's interface. IP NAT inside interface. Oh, let me look for it. Okay, I've seen it. Okay, I've seen it. IP NAT inside source list 1. Our access list will still be there. Interface G0/1. G0/1 overload. What am I doing? My list one is pointing to my private IP. It has qualified my private IP. Look at what I'm saying. Interface G0, any IP address on that interface, use it to do part for me. And hit enter. IP NAT, inside source, list one, interface G0/1 overload. With this, I don't need to create any pool because I am going to use the IP address on the interface of my router. Or let me put it this way, I'm going to use the public IP address on the interface of my router on that interface. So I will only create the list with access list. And then the second command is IP NAT inside source, list one, interface G0/1 overload. Just one public IP. Just one public IP will be used to take care of the needs of our organization. That is if the service provider decided not to give you pool of addresses, if you don't really need it, the address on this interface, the public IP here, will be used to NAT, to do parts, to go out. And that address can take care of 65,535 because we configure part on that interface. That is part now, yeah. That is part. Once anywhere you see overload, that is part. NAT overload. That is how we do it. If you are not given a public IP addresses, you are not given public IP address to create your pool, you just go and use the interface, the IP address on that interface, and everything will work perfectly. But now, with what I designed, I put private here so I can demonstrate this to you guys. If I need to demonstrate, I need to go and look for what do you call it? Jack up this one, put our private IP. I mean, put the public IP. We can do that. Let's do that quickly. And test run this also so that I will know that I've done justice to NAT in this class. So let me get rid of this IP address here on my G0/1. No IP address. Then I'll say IP address 200.100.100.1 255.255.255.252. No short. Okay, I've done that before. Then go to the other interface. No IP. IP 200, 100, 100.2, 255.255.252. Now I've done no show that before, so let's ping the other side and be sure we can hit it. Beautiful. Okay, go to the other side. So now I have yanked off my IP NAT insert list one pool this, so I have replaced it with this. So what is going to happen? This .1, 200.100.1 is the only address that will be used to do translation. So let's clear our table. Show IP NAT translation. Let me clear this one. Why do I have this one here? Okay, my static NAT that I did for what's it called? For Ali to come in. That one will always be in your NAT table. Even if you do clear IP NAT translation, it will still be there because it's static. So it's still there. So now let's now ping where we've been pinging before and see what's going to happen. So we're pinging our imaginary Google server. Why are you telling me destination was unreachable? Oh, my goodness. I think my this thing is conflicting. My pool that I created earlier that I couldn't kill. If I cannot make this work, I can't promise you guys I will get this one again. This is going to be the last class, but I will try to do it before I teach another set, not your class. So let me see again. The pool came out. That's good. So let me try now to ping again. Destination host unreachable. So let's see our NAT table and see. Show run. IP NAT. Inside source list 1. Interface gigabit 0/1 overload. So let's see something. Show IP interface brief. I'm good there. Oh, let me try the other guy. If that one can go, I don't think this one can go too. Destination host unreachable, troubleshooting, not in this class. Why is our path using the interface not working? It could be a packet tracer issue. It could be that I'm missing something. So I wouldn't know now because this will be the first time I'm trying to demonstrate this. I've always done the pool, created the pool, and make it work on the router. So if we meet again next year, maybe I will have been able to solve this problem. That is where I'm going to stop the class. Any question? Sometimes it's good to run into trouble. Then you are going to now look for solution. Any question, guys?